Assalamualaikum, hello everyone. Aspect here. We are from Anak Spectator Team, Jakarta, Indonesia. There are several points that we're gonna talk about, including background, reason, existing result, implementation, improvement and reasoning, result, documentation, local development plan, business pitch, and go-to-market proposal. Let's take a look to our background. According to a survey from Microsoft, Indonesia has been named the most disrespectful netizen in Southeast Asia on their Digital Civility Index regional summary, representing the level of politeness of netizen. Indonesia in the last position of Southeast Asia. The cause of this problem is the lack of moral education and parental supervision of their children. So they do not know or do not understand how to speak properly and politely, including hate speech, discrimination, and bullying.
Lack of moral education causes people in Indonesia to be less able to maintain a good and polite attitude toward others. In Indonesia itself, we often encounter people who speak inappropriately and not will. We want to solve this problem by creating a monitoring application for parents toward their child so that it's easy to find out all their child attitude and development. With an application that we can make it easy for parents to monitor the work of their children.
Existing result. Google Family Link for parents and for children provides parental monitoring apps. The feature includes activity reports, manage apps, apps recommendations, screen time limit, lock children device, and location tracking. There is no keyboard monitoring features in the existing applications. Parents can monitor their children if they are typing bad words while using their phone. There are also web apps for bad words detections, such as Profanity Detector and Word Safety, but it's not for parental monitoring.
For the dataset, we combine Indonesian abusive and hate speech tweet and Instagram cyberbullying comment datasets with some adjustment on the labels. The final dataset has two columns. One contains the tweets and the comments, and the other one indicates whether the sentence contains bad word or not. Currently, we have two versions of the model with some differences in the data pre-processing steps, as you can see in this slide. The steps we added in the second version include removing repeating letters at the end of the word, transforming non-standard words to the standard one, and removing stop words.
For machine learning models, for architecture, the model consists of trainable 128-dimensional pre-trained embedding and the other 6 hidden layers, with 5 of them are directional STM layers. The output layer is a single neuron dense layer with sigmoid as its activation function. And for the training, we split the dataset into training, validation, and test set with proportions of 80%, 10%, and 10% respectively. The model is compiled with Adam Optimizer and binary cross entropy as the loss function, then trained for 20 epochs.
Jump to a closed section, or we call it backend. We use Golang for handling main services. We use Golang because it is typed and compiled language. And the result of that, we receive a faster server for serving to client. And framework that we actually use is Fiber. It is faster server that can, is friendly developer because it is rapid for development. And if you want to see a benchmark, just take a look at this benchmark. Fiber can achieve so many good coin on that. We implemented event-driven architecture because Python is not gonna run so fast, and our services is pretty need to fast. So we implemented event-driven architecture for build microservices between each service. And the database that we actually use in this project is SQL. The reason why we use SQL because our data is so much relation, and SQL doesn't require a lot of memory, and a table is very flexible and easy to manage. So that's why we use SQL for it. But not only that, we use a lot of it. But if you want to take a look more, just go to our repo in the main or official repo from Expect if you want to see more. So just take a look.
We use Python, Flash as machine learning service and bridging all the requests right to the AI platform. But for now, we still under development. We will soon replace all mock service with the full feature of the service. For machine learning service, we implement model view controller pattern from the project architecture.
Okay, now for the keyboard, we use open source code written in Java from GitHub, but however, we make some changes in the code to adjust the needs of our project. The keyboard will send a post request to the server to detect if any bad word is found. And the request is made using Folio library to get JSON object from the server. In the parent app, we code that with Kotlin language. We adjust the ID from each parent with their child. So the parent can only know their child text in the app and not someone else's child.
Both versions of the model get above 85% accuracy, with the first version is slightly better, but the validation loss on the second version decreased by 20%. You can see the conversion matrices on the test set for both versions below. One of the problems that we notice is our model performance when dealing with words that can have multiple meanings, which in most cases are animal names.
This is our parent app look. We develop it use some library like Glide, Recycle View, and others. And then this is our children apps look in our project.
If you want to build a similar model and deploy it to your GCP, you can run the bad word detection.ipynb or bad word detection v2.ipynb notebook. Please make sure that you change the value of some variables, currently is an empty string, in the deployment section to match your GCP information. You also need kaggle.json file to download some files, including a dataset from Kaggle platform.
Thus is for Android documentation. We use Folly to make requests to the server. All documentation written in the link below. And the second is for parent app, is using Recycle View library, data material design for UI, and the link access below for more information.
In the initial 2 months, our focus is on making the initial structure of the app and so much researching more about a feature we can develop at the beginning. And in the 3 to 4 months, we are focusing on implementation and pre-planning everything for develop into the real apps we need to make it. In this timeline, we will focus on what we agree at the beginning about a feature we are pursuing in the first version and what market we want to target it.
The next is business pitch and go-to-market proposal. There are 2 points. Who is our target market and how we sustain? Our target market is parents and children on age 6 to 17, according to Indonesian government. And then, why we choose this our target and why they need our solution? First is parent wants their children to have a good texting attitude. Second is based on the DCI index released by the survey. And then government reasoning to national identity and character building. And how we sustain, first is our sales. We sell theme, icon, and stickers. So there are a subscription plan for the user, including a free, a pro version, and education. And the third is funding. Okay, here's our team, and see you next time. Thank you.